Hi everyone, this is Dr. G. Ravindranath Reddy, working as Assistant Professor in MLR Institute of Technology, Hyderabad. So we are in Numerical Methods and Integral Transform course. In that course, we are discussing root finding techniques. In that root finding techniques, we are discussing about Regula Falsi method. So in this video, we are discussing Regula Falsi method, how to use this Regula Falsi method to find out the root of an equation. So we will take some examples and we will see how to use this Regula Falsi method here. So before that, we will take the working procedure of false position method or Regula Falsi method. So this Regula Falsi method, we can also call it as a false position method. So once again I will repeat, Regula Falsi method is also known as false position method, and by using this method, we are going to find out the root of the equation f of x is equal to 0. So this is the standard form of that equation, f of x is equal to 0. For this, we are going to find out the root using false position method, or we can call it as Regula Falsi method. So first what we have to do is, we have to consider two real numbers x0 and x1. So this is x0 and this is x1. So now if you substitute this x0 in the function f of x, you will get the value of f of x0. And similarly, you substitute this x1 in the function f of x, so you will get f of x1. So suppose this f of x1 is a negative sign, so this is a negative value and this must be a positive. So whenever we substitute these two real numbers in the function f of x, their function value must have opposite signs. So whenever we are having opposite signs for these two real numbers in the function, then we can conclude that whatever the root we are going to find out, that root lies between these two real numbers. So like this, we have to consider two real numbers x0 and x1. So then we can conclude that whatever the root we are going to find out, that root lies between x0 and x1 here. Now by using this Regula Falsi method, if you want to go for the next approximation x2, so this is the standard formula we will use. x2 is equal to, so this is very simple to remember this formula. So let us see how to remember this formula here to find out x2. So now in our hand we are having x0 and we are having x1, and this function is f of x0 and this function is f of x1. Now we are going to find out the formula to find out the first approximation using Regula Falsi method. Now you cross multiply these two. So x0 into f of x1, x0 into f of x1 minus, next you multiply these two, cross multiplication. So x1 into f of x0 by, write down these functions as it is, f of x0, f of x1 minus f of x0. So once if you remember this process, then we can take any formula for any approximation using Regula Falsi method. So whatever the two real numbers we are having, you take the two real numbers and its function values and apply the cross multiplication, then we can get our approximation value using Regula Falsi. This is our formula here. So this is very simple how to remember this. Now we got x2 value. Now you calculate that f of x2. So now you substitute this x2 value in the function, you will get f of x2 value. Suppose if f of x2 value is equal to 0, then we can conclude that this x2 is the root of this equation. Suppose if it is not equal to 0, then any one of these two cases you will get. So this f of x2 value, it may be a less than 0 or it may be greater than 0. If it is less than 0, we will get negative value. If it is greater than 0, you will get a positive value here. Okay. So now after finding, suppose if f of x0 value and f of x2 value are of opposite signs. For example, if you take this number line here, so this is x0 and this is x1, and suppose f of x0, imagine that for f of x0 we are having a negative sign, for f of x1 we are having a positive sign. So in this, in between this, we have taken one root, that is x2, and we got that x2 function of that x2. Suppose if that function of x2, f of x2 is a negative value, then we can neglect this and we can take this x1 and x2 for the next iteration. And suppose instead of this, if we get here, so if we get this f of x2 value as a positive value, then we can neglect this x1 and we can go for the next approximation in between x0 and x2. Okay, like this we have to follow until we get a desired accuracy. So this process is repeated many times until we get our desired accuracy. What is meant by desired accuracy here? Suppose we are in that, you are at x5 fifth approximation, and now if you want to stop the problem at fifth approximation, so whatever x value we got in the fifth approximation, that must coincide with the previous approximation, that is in the fourth approximation. So these two values, minimum 3 decimals after decimal point, 3 digits must coincide after that decimal point here. So then we can stop the problem and we can conclude that the desired accuracy is obtained, and we can conclude that whatever the x value we got in the final step, final approximation, we can consider that value as the root of this equation. So this is our procedure in Regula Falsi method. So now we will take an example and we will follow this procedure and we will see how to get this required root for the given equation. So now this is our problem. So find a real root for the equation e power x into sin x is equal to 1 using the Regula Falsi method. So this is our equation, e power x into sin x is equal to 1. Now here what we have to do is, this is not our standard form. Our standard form is f of x is equal to 0. In the RHS side we have to get that value is equal to 0. So now in order to reduce this into standard form, you bring this 1 to this side, you will get e power x sin x minus 1 is equal to 0. Now compare this and get the value of f of x here. Okay, so now here this is our f of x value, e power x sin x minus 1. Now we got the function, that is the first step here. Now the second step is, we have to consider two real numbers. We don't know what are the two real numbers here. So by default I will start with x is equal to 0 and substitute this f of 0 value. Here one thing we have to remember, that in the function we are having a trigonometric, in that equation we are having a trigonometric function. So whenever the trigonometric function is involved in the function f of x, then if you want to find out this f of 0 value or something, that value f of 0, f of 1, f of 2, f of 3 like that, then before that we have to keep our calculators in the radians mode. That is the important point. So once again I will repeat this. So whenever we want to find out a function value, in that if any trigonometric function is involved, then if you want to find out this f of 0 or f of 1 or f of 2 and so on, then before finding this f of 0, f of 1, f of 2, then we must keep calculators in the radians mode. By keeping that calculators in the radians mode, then only we have to start finding f of 0, f of 1, f of 2 and so on. That is the important thing we have to remember here. So now I have started with x is equal to 0. Now we got f of 0 is equal to minus 1, that is a negative sign. Now let us go for the next number, x is equal to 1. So when we take x is equal to 1, we got f of 1 with a positive value 1.2873. So here we are having a negative sign, here we are having a positive sign. So whenever we substitute x is equal to 0 and x is equal to 1, their function values having opposite signs. So whenever we are having a function values in the opposite signs, then we can conclude that whatever the root we are going for this equation, that root lies between x is equal to 0 and x is equal to 1. So now whatever the x value we get, that x value lies between 0 and 1. So since f of 0 and f of 1 are of opposite signs. So we can conclude that the root lies between 0 and 1. This is the conclusion. We can come to that conclusion by considering this f of 0 and f of 1. Now it is very clear that whatever the root we are going to find out, that lies between 0 and 1 here. So you consider that x0 is equal to 0 and you consider that second number as x1. So x0 is equal to 0 and x1 is equal to 1. Now by using these initial values, we are going to find out the first approximation using false position method. Okay. So now by using our false position method, this is our formula to find out our x2 value. So I will represent that x0 and x1 here. So this is our x0. So we got f of x0 with a negative sign. x0 is equal to, we have considered as 0, and the next number is x1 is equal to 1. We got f of x1 with a positive sign. Now we are going to find out the value of x2. So in order to find out the value of x2, I am using this standard formula to find out this x2 value. In the working procedure, we have seen how to remember this approximation value to find out this formula to find out the x2 value here. Now already we got this x0 value, f of x1 value, x1 and f of x0. You substitute all these values in this function and simplify, then we can get our required x2 value here. So after simplifying this, we got this is our x2 value. So x2 is equal to 0.4371. Now we got 0.4371. Now I want to substitute that value in the function and we'll decide whether you will get a positive value or negative value here. So now f of x2. So here we got with a negative sign so minus 0.3446. So represent this negative sign. Now as usual, whatever we have discussed in the bijection, follow the same procedure. So here positive sign is not repeated and the negative signs are repeated. Now you consider the negative sign which is nearest to this positive sign. So we can, it is very clear that x2 is very nearest to x1 when compared to this x0 value here. So neglect that x0 and you consider this x2 and x1 for the next approximation. So for the next approximation, we are taking x2 and x1. So f of x1, we are having a positive sign, and f of x2, we are having a negative sign. So now I am going for the next approximation, x3 here. So now we will take the formula how to get this x3 value here. Now whatever the real numbers we have considered in this, you represent these numbers here, x2, x1, or if you want you can take x1 and x2, no problem. So f of x2 and f of x1. Now cross multiply this and cross multiply this, you will get our, so this is our formula. So x2 minus x1 by in minus x1 minus x2. If you take minus common from the numerator and denominator, you will get this value. So no need to worry about this. This is the process how to get the formula to find out x3 value here. So this is our x3. So as usual, you substitute that x1, f of x2 and so on this. So these are the values we get. If you calculate this, you will get our required value is 0.x3, 0.559. So represent this 0.559. And now you calculate this f of x3 value here. So if you calculate this f of x3, so you will get this value is equal to f of x3. We got this value with a negative sign. So keep negative sign here. Now once if you observe this, we are having two negative signs. This is one negative sign and this is one negative sign along with one positive sign. So now you identify the nearest value for x1. So from this it is very clear that x3 is the nearest value for x1. So you cancel this. Why you are taking x1 here? Because positive sign we got only one time. So the sign which is not repeated, go to that sign. From that you identify the nearest value, either x3 or x2. So it is very clear that x3 is nearest to x1 than compared to x2. So you cancel this x2, and for the next approximation you consider x1 and x3. Because we are having f of x3 is negative sign, f of x1 is positive sign. So for these two function values we are having opposite signs. So we can conclude that our next root lies between x1 and x3. So that is the point we are going to take in the next slide here. So that's x1 and x3. Once again you represent this x3 and you take this x1, and f of x1 we got a positive sign, f of x3 we are having a negative sign. Now we have to go for the next approximation here, x4. So follow the same procedure and get the formula to find out that x4 value. Then substitute that values, you will get x4 is equal to 0.5818. Now you calculate f of x4 here, and let us check whether you will get a positive sign or negative sign here. So if you take f of x4 we got this value is minus 0.0167. So we represent that f of x4 with a negative sign here. So once again in this figure the negative sign is repeated twice and the non-repeated sign is positive. So you are at this x1. From this x1 you identify the nearest value. So it is very clear that x4 is the nearest value than compared to this x3. So neglect this x3 and take x1 and x4 for the next approximation. So represent this. This is our x4 value and this is our x1, and follow the same procedure here for the next approximation, f of x4 with a negative sign, f of x1 with a positive sign, and now find out the next approximation, that is x5. So here, so the root lies between x1 and x4. Already we have decided this. So now this is our formula to find out this x5. So here, see in the previous slide we have seen how to get this formula to find out the x5 value here. So take x1, whatever the roots here, whatever the real numbers we have considered, you take that real numbers x1, x4 and f of x1 and f of x4. Now apply the cross multiplication here, x1 into f of x4 minus x4 into f of x1 by f of x4 minus f of x1. So this is the way how we can remember this formula to find out the approximation values in the false position method. Now we got, after simplifying this x1 and f of x4, x2, x4 and f of x1 values, we got x5 is equal to 0.5871. So this is our value. So now here we can repeat this process until, suppose if you want to stop this problem here. So we are at the x5. The next previous approximation is f of x4. Now if you want to stop the problem and if you want to conclude the root of that equation, now you compare this x5 and x4, and at least after decimal point 3 digits must coincide here. So here 58, first 2 digits, here 58, and here the third digit is 7, and here we are having the third digit is 1. So here the third digit is not coincidence, so we can go for the sixth approximation, follow the same procedure and identify that calculate that x6 value and check this x6, compare this x6 value with x5 value, and if this three digits or 3 decimals after that digit, so suppose if you get 0.587 something, if you get this, then after decimal point the 3 digits 8587, if these 3 digits coincide with the previous approximation, then we can stop our problem and we can conclude this is our required root for the given equation. So this is the way how we can find out the root by using false position method or by using a Regula Falsi method. So here in this problem one important thing we have to remember is, so whenever we are having a function in the trigonometric form, suppose any trigonometric function is involved in this function, then if you want to find out that f of x1, f of x2, f of x0, so if you want to calculate any value, then keep our calculators in the radians mode. And not only in this method, in any method, whenever we want to find out that function value which contains trigonometric function, in any method we have to keep our calculators in the radians mode. That is the important thing we have to remember here. So this is the way how we can use this Regula Falsi method. So in this video we have discussed the procedure of Regula Falsi method, and we have seen how to find out the root for the given equation using Regula Falsi method. So in the next video we will go for the next root finding technique, that is Newton-Raphson method. Thank you.